So 50 years ago, when the National Academy was being created, the seeds of the internet had already been sown, and we were thinking about such a network. But the vision for that network came much earlier. In fact, we learn of a quote by someone you'll recognize in just a moment, who said that a businessman in New York, using an inexpensive device no larger than his watch, would be able to communicate instantly anywhere across the world, on sea or land, and transmit print, drawing, text, characters instantly and easily. That man was talking about the internet, but he did so in 1908. Name was Nikola Tesla. So the vision's been around for a while. And in the 30s, H.G. Wells was talking about a world brain, a depot for knowledge. In the 40s, Vannevar Bush was talking about Memex, where we could get our collective memory on a machine. In the 60s, J.C.R. Licklider was talking about man-computer symbiosis. Later in the 60s, I was talking about this network which we were about to build, which would be always on, always available. Anybody with any device could get on at any time, from any location, and it would be invisible. Well, it's not yet invisible, unfortunately. We'll talk about that later. But as we embarked upon the creation of the ARPANET, which led to the internet, as engineers, we had done our homework. We had a theory, a model, we had analyzed it, we knew how it would behave and how to optimize it. But as engineers, we also knew that we didn't know, that we had to experiment with this thing. This was an experimental network, so we built in the measurement tools, basically the ability to generate traffic, to test it, to try to break it, and learn from that experimentation. As we all have done, we know the wonders of engineering come out when you try something and you discover things you didn't anticipate, and then find out why they're behaving that way and how to fix it. So the engineering approach to this was critical. It's not as if we designed something, built it, and let it go, because it wouldn't have worked. We needed to correct it along the way. Now, ARPA, Advanced Research Project Agency, that came along, decided they needed a network to share the resources, the computing resources, the applications, the services, the hardware, among their many researchers. And so they launched upon this network. And what you should realize is that the very early culture that existed in that time was one that was an open culture. It was shared. We trusted everybody. We knew everybody that was coming into the network. So we didn't put in many impediments, called that security measures, to protect against bad behavior. And in fact, the gratification that we received as engineers was not to build a system to make money, but simply to build a system. As nerds, just building it, and the gratification we got was when other people used the things that we put down and made available. So the network came to life in the late 60s, 1969, and once we had 2 nodes up, UCLA and Stanford Research Institute, we decided to test it. We had a 2-node network, so we wanted to send the first message from UCLA to SRI. Now, Samuel Morse, years ago, had sent a great message, what God hath wrought. Alexander Graham Bell, come here, Watson, I need you. Neil Armstrong, a giant leap for mankind. Those guys were smart. They understood public relations. They had photographers. They had written documents. They had a record of what they did and a good message. We had no such idea. There was nobody around. There was no camera, almost no written record. And all we wanted to do was log in from one machine to the other. Now, to log in, you have to type LOG, and the machine at the other end understands what you're trying to do. It'll type the IN for you. So job is just type LOG. So we had this network, and one of our programmers typed the L, and to be sure it got there, he had a telephone talking to the guy at the other end. Now, understand, we're using a technology called telephony to prove a new technology which is going to undermine technology. But we needed the old technology to make sure. So Charlie said, did you get the L? And it came back, got the L. Type the O, you get the O, got the O. Type the G, get the G, crash. So the first message on the net, the internet, ever was lo, as in lo and behold. We couldn't have asked for a better message, by luck. But nobody knows it. Hopefully someday it'll be as popular as come here, Watson, I need you. So the internet grew very nicely from 1969 to 1988. In 1988, the first worm escaped. And we noticed it. It was all over the place. And we said, uh-oh. And then we said, oh, well, it's an aberration. What a mistake. From 1988 to 1994, things went along fine until the first broad spread, widely understood spam message came from a couple of people named Cantor and Siegel. They were trying to sell their services as lawyers to help people get green cards. This was all over the net. We said, uh-oh, and we said, ouch, that one hurts. How dare you use our experimental network, a research network, for commercial reasons? Mm-hmm. And so we sent messages back to them. We said, you shouldn't do that, bad, stop, shame on you. We sent so many messages back, we took down their server. So the response to the first spam message was the first denial of service attack, inadvertently. So if you think about it, what the internet allows people to do, allows anybody, short, pimply, ugly, dirty, to reach out to millions of people instantly, easily, at no cost in money or effort, anonymously. Well, that's a perfect formula for the dark side of the internet. And sure enough, the dark side emerged as spam began to propagate. And now the technology was different, and the world was and is different in terms of the bad things that take place, as well as all the wonders. But our younger generation now can't conceive of a time when they couldn't share their photos, chat with their friends, stream video, shop online. And while all that's taking place, there are disruptive forces, technology, engineering forces at work. For example, everything is getting digitized. That's a disruptive event. Basically, the explosion of broadband, wireless and wired. Devices are getting smaller, smarter, faster, cheaper. That's a disruptive technology that we are producing. Mobile applications are changing the landscape, and the Internet of Things is being deployed as we speak. These are not small effects. They certainly change the landscape dramatically. Enormous changes, enormous opportunity. And yet the Internet itself is still a teenager. And it's acting like a teenager. It's mischievous, it's erratic, it's unruly, and it's disobedient. And the hope is that it will mature and grow up into a properly behaved adult. We're not sure. We hope it'll happen. So what's the future? The future consists of convergence of content, technology, applications, services, function. We're seeing them converge into devices that we carry around. The future will be one of extreme mobility, mass personalization, video addiction, location-based services, surprising apps, and, as we know, dramatic society and lifestyle changes. So a reversal has taken place. We've seen a tipping point recently. It used to be that we developed technology as engineers, and the applications would follow. Here's a technology, here's an application that can use that technology. Well, these days, over the last few years, we've seen the applications racing ahead of the technology, and technology is chasing behind, trying to catch up to serve the needs of those applications. A serious tipping point has occurred. And yet, the beauty of the design of the network we talk about as the Internet today is that it was designed so it would not preclude unanticipated services and applications and technologies. They come, the PC wasn't invented when the Internet began. Mobile applications weren't there. They all come in, and the technology is adaptive enough and general enough to allow these things to blossom, if you will. So, applications. Most of these significant applications have come as a surprise. They've hit us in the side of the head they've suddenly come and taken over. Examples: email, the World Wide Web, peer-to-peer sharing networks, social networking, blogs, the ability to users to generate and use and ship around music, photos, videos. So in terms of predicting the technology, we can see what's happening. In terms of predicting the applications, what we can predict is that we'll be unable to predict those applications. And when they come, they're usually surprising and delightful, and they take over very quickly. So in summary, the internet will essentially be a pervasive global nervous system. It will be everywhere, and hopefully at some point it will be invisible and you won't have to mess with it. Thank you.